Phase diagram for 5.4, which is a graphical representation of the physical states of a substance under different conditions of temperature and pressure. Learning outcome. First one, we define phase, triple point, and critical point. And also, we try to identify triple and critical point on the phase diagram. And next one, we try to sketch the phase diagram of H2O and CO2. For phase diagram, actually pressure versus temperature, the diagram show the three regions of single phase. ATB represents solid phase, BTC represents liquid phase, ATC represents gas phase. If we take a look at the phase diagram of H2O right now, we have the graph, the diagram represent pressure versus temperature, which is have to mention line TC represent variance of boiling temperature with pressure, and line TB represent variance of melting temperature with pressure, and also line TA represent variance of sublimation temperature with pressure. Okay, we have a two term right now. If you take a look, we have triple point, we also have critical point, alright, which is triple point, the equilibrium for three phase, which is for solid, for gas, and for liquid. And then critical point, a point which is have no boundary within liquid phase and the gas phase. Okay, next one, we take a look at the describe for the compare phase diagram H2O and CO2, explain anomalous behavior of H2O, and try to take a look example describe chain which is in phase, temperature at constant pressure and pressure at constant temperature. So, if you take a look by comparison between both diagram right now, first part we have CO2, second part we have H2O. Actually, for the region at the single phase, equal same within both, which is ATB represents solid phase, BTC represent liquid phase, BTC represent gas or vapor phase. But at the same time, we try to highlight the phase, first one. The next one, we also try to highlight the process. That means the process example, solid change to liquid, liquid to the gas, or solid directly to vapor. We also can represent using this diagram. Alright, and also one more describe about line for both, which is AT line represents solid vapor at equilibrium, TC line represents liquid vapor at equilibrium, line TB represents solid liquid at equilibrium. In this case, please observe line TB for both. Line TB for CO2 also we can call positive slope. Line TB for H2O we can consider negative slope, which is we have a little bit describe about negative slope that we call anomalous behavior of H2O, which is have the phase diagram of water. It's not typical. So, which is line TB slope to the left or negative slope, which means that increase in pressure, the freezing point of water or melting point of ice decrease. Why this happen? Because ice is less denser than water. And also one more, I'd like to share with you right now for both, right? Okay, we have pointing represent triple point, which is solid, liquid, vapor at equilibrium. For both also, critical point we have water vapor cannot be condensed to form water, and not matter how high the pressure applied, so we cannot separate within liquid or gas. And last one, highlight the pressure at 1 atmosphere. have a normal boiling point at line TC and normal freezing point at line TB. So one more, okay, for sharing. If a data given, you need to smooth the diagram, which is pressure versus temperature. Highlight. First one, if data given by triple point, by critical point, you find the point and smooth the curve. And make sure is it H2O or CO2. Depends on the data given. So you need to smooth the curve. And next one, label. And we try to highlight right now. You try to represent what phase, the region, space mentioned. Second one, we try to highlight the process. You also can observe which is H2O starting with 0 and CO2 starting with certain amount. And take a look the example right now. If we try to study, which is have a constant temperature with the decreasing of pressure, what happen if you try to observe the phase change within T to the P or P to the T. Okay, first we take a look. P was the gas phase. Q, we have gas and solid phase at equilibrium. R, we have solid phase, and S, solid and liquid phase at equilibrium, and T have a liquid phase. So please observe the changes and consider what phase we have within both, maybe constant temperature or maybe constant pressure. So you need to highlight and take a look very clearly what the sample given.